All right, today we are diving into something that might just flip your whole understanding of the universe on its head. It's a pretty radical idea called motion theory, and trust me, it forces you to rethink, well, everything.
So let's just start with a massive, foundational question. We're all brought up to believe the world is made of stuff, right? Particles, matter, little tiny bits of things. But what if that's not right? What if the universe isn't made of anything at all, in the way we think of it? So here's our roadmap for this little journey. First, we're going to look at the core idea. Then, we'll basically have to redefine reality from the ground up. After that, we'll see if this new perspective can actually solve some of physics' biggest headaches. We'll ask if it's real science, and finally, we'll imagine what the future might look like if it's all true. Okay, so what's the big paradigm shift here? It's really simple at its core. We're getting rid of the idea of a universe made of stuff and replacing it with a universe made of pure, structured motion. That's it.
This sentence right here, this is the central axiom, the one rule to rule them all. I want you to think about an ocean for a second. We see waves and we see whirlpools, right? We give them names, but underneath it all, it's all just one thing, water, that's moving. This theory says reality is just like that. Particles, forces, you, me, we're all just different patterns, different ripples, in one single underlying ocean of motion.
But wait, if everything is just motion, then what on earth are things like mass, or energy, or even time? Yeah, to really grasp this, we have to throw out our old dictionary and start defining these basic words all over again.
Let's start with mass. We usually think of it as just how heavy something is. But in this new view, picture a really stable, heavy spinning top. It's hard to knock over, right? It really resists any change to its spin, its rhythm. Well, according to motion theory, that resistance is its mass. It's literally the cost of trying to mess with its specific pattern of motion.
So you see the shift? We're going from something static, like a brick just sitting there, to something dynamic and active, like a wave. Inertia isn't just some random property an object has. It's a direct result of what the object is, a stable, self-reinforcing dance that naturally wants to keep dancing the same way.
And energy? Okay, forget the idea that it's some kind of substance that flows around. Instead, imagine a tightly coiled spring. The energy isn't some separate thing in the spring. It is the tension in the spring's structure. That tension is its potential to uncoil and do work, to change the motion of something else. That's what rephasing work means, using your own pattern's tension to alter another's rhythm.
So all of a sudden, all these different forms of energy we learn about, kinetic, potential, chemical, they stop being different things. They're all just various kinds of tension inside different patterns of motion. It's all unified.
Now for the big one, time. This might mess with your head a bit. Motion theory says time doesn't actually flow. It's not a river we're all floating down. Instead, time is just what we do when we compare different rhythms. A clock doesn't measure some invisible fourth dimension. It just provides a really steady, predictable rhythm that we can measure everything else against. Time is just the bookkeeping of change. Okay, so we have a new way to define mass, energy, and time. That's kind of neat, but so what? Can it actually do anything useful? Well, let's take this new lens and point it at some of the biggest unsolved mysteries in all of physics. Let's start with the one we feel every single day, but still can't fully explain. What is gravity?
That theory's answer is completely wild. It says gravity isn't a pull at all. Imagine you're in a huge room and everyone's clapping out of sync. It's chaotic, but then a big group in the corner starts clapping together. It's just easier, more natural to start clapping along with them. Motion theory says gravity is just like that. Objects naturally drift toward places with more synchronized motion, like a planet or a star, because it's the easiest, most stable, lowest tension path for their own pattern to follow.
Next up, another classic mystery. What in the world is light? Is it a particle? Is it a wave? Which is it?
From this point of view, that whole wave-particle debate is kind of asking the wrong question. Light is simply a ripple, a pulse of synchronized motion, traveling through the universe. And its properties just naturally fall out of that definition. The color? That's just the frequency of the ripple's rhythm. And its brightness? That's just how intense the synchronization is. This whole synchronization idea isn't just a metaphor. It's a real thing you can see. If you take a bunch of metronomes, put them on a board they can move a little, and start them all at different times, just watch.
The tiny vibrations they send through the board act like a communication channel, and after a little while, they will all be ticking in perfect, beautiful unison. That's it. That's synchronization emerging from motion under constraint.
And this very same principle might just explain quantization. You know, the super weird fact that energy only seems to come in these little discrete packets or quanta. Think about a guitar string. You can't make it vibrate at just any old frequency. It only sustains clear, stable notes, the harmonics. Those stable patterns are like rhythmic closures. So quantum levels aren't some deep, spooky mystery. They're just the stable notes that the universe allows patterns of motion to play.
Now, I know what you might be thinking. This all sounds incredibly elegant, maybe a little too elegant. So we have to ask the most important question of all. Is this actually science? Or is it just some cool philosophical idea? Because for it to be science, you have to be able to test it.
And that's the mark of a good theory. It makes bold predictions that could be proven wrong. Motion theory says gravity is caused by synchronization. So, if we found a situation where more sync led to less gravity, boom, the theory's broken. It says everything is rhythmic motion. So if we found a stable particle that had some fundamental, non-rhythmic part, the theory's broken. It's a real scientific model.
And this is super important. The point isn't to throw out the last 100 years of physics. The goal is to give it a deeper foundation. In this view, Einstein's relativity just becomes the beautiful mathematics of how you compare rhythms from different points of view. And the wave functions of quantum mechanics, they become mathematical tools for describing a system's possible rhythms, its potential to be in one pattern or another.
So here's the elevator pitch you'd give to a skeptical physicist. It goes like this. We're replacing the basic building blocks of reality, stuff and forces, with something much simpler: structured motion and constraints. And from that incredibly simple starting point, we get a single, unified mechanism, synchronization under tension, that explains quantization, inertia, and gravity, all at once.
So let's dream for a minute. Let's say this is right, or even partly right. What would that actually mean for us? For technology? For the future? What could we do with this new paradigm?
I mean, if this is truly how reality is built, the applications are mind-boggling. Imagine spaceships that don't work by pushing stuff out the back, but by actively steering the patterns of motion around them. Or computers that don't use electricity, but calculate using rhythms and frequencies. You could even imagine medical treatments that don't use drugs, but use precise frequencies to restore the healthy, synchronized rhythms of our own cells.
And really, that's what it all comes down to. This isn't just an answer. It's a new, more powerful way to ask questions. The theory's motto is a challenge to all of us. It's saying, look deeper. Don't just accept labels like particle or force. Always, always keep asking the fundamental questions. What is actually moving here? And what is that movement doing? Thanks for tuning in.